Oh boy, am I hungry. I want fries, a hamburger. No, make that 2 fries. You want anything? What's your special today?
Episode 2. Welcome back to the Northwest Builders Lunch Hour. Today we'll be enjoying episode 3 of a 3-part series, talking with Luke Moerke and Chris Bzdel of Exodus Engineering. In the last couple of episodes, we talked about how Chris and Luke ended up in the engineering field, and then we talked about the services that Exodus provides and how you, as a builder, can prepare yourself to have a great experience working with an engineer. Today, we're going to talk a bit more about what Luke and Chris see coming up in the future in our industry. And also, bonus, they're going to do a bit of an interview of me. So grab some lunch, something to drink, and sit back and enjoy. Well, welcome back to the Builders Lunch Hour. We're talking here with Luke and Chris. And next question we're going to tackle is how can a builder prepare for going to see the engineer? What should they do? What should they bring? How can they make it a smooth and absolutely painless experience? Or as close as they can to that.
What do you think, Chris? What's your feedback on that?
I'd say the best thing a builder can bring is basically a list of everything that they do that they build specifically. We could take that set of plans, and it's great to talk with the builder and know exactly how they want to build things, and then we can provide those exact details to them. And we have details for every situation imaginable. So for us to know exactly how they want to build it definitely helps us out on our end, so we're just not guessing or having to provide RFI letters after the fact to convert that plan into something more like what they want to build.
Mm-hmm. So that makes it sound like it is definitely not a one-size-fits-all.
Correct.
Yeah. Okay.
Yeah.
What are some options that they might have for how they would build? Because it sounds like I could bring you the A structure, and you could design it in a few different ways.
Yeah. So basically, just starting from the foundation going up, typically we do poured concrete foundation, but there have been instances where people have wanted to do CMU, so that is doable. It's just not common in this area. And then going up to the floor joist, you got your I joists or your solid sawn joists, and do you want them hung, or do you want a stacked floor joist, a rim joist configuration? And
Don't forget floor trusses.
Oh yeah, floor trusses are an option as well.
Couldn't let that go.
And your pre-built walls. Yeah, and then going up to the roof up above. Do they want to use trusses? Are they okay with rafters that are called out? And just getting all the specifics from the builder and exactly how they want to build it, so we can detail it just to their specifications.
All right. Any more that you'd want to throw in there, or is that pretty well cover it?
Well, after I take a sip of Starry Lime, yeah, I think Chris covered some good items. I think oftentimes builders maybe have the perception that they don't want to send things to the engineer because all the engineer is going to do is add costs and spec overkill this and overkill that. Yeah, they did kind of the usual. I mean, I do from the onset, and based on how we started the conversation, I used to be in the field. I was a technician in the field working on systems and saw how frustrating it was when it didn't seem like there was much common sense put into things. So we try to have a down-to-earth and common sense approach. Like if there was a slogan for Exodus Engineering, it'd be down-to-earth and common sense approach.
I like it.
And we still have to design to the codes. We still have to meet the building codes. And so does that mean you're going to have hold downs? Well, yes, you very well may need hold downs because the seismic and wind loads determine that.
Yeah.
But what kind of hold downs do you want to use? Do you want to use embedded straps? Do you want to use bolts with concealed fasteners in the wall? Do you want to use nails? Do you want to use screws? What kind of sheathing do you want to use? If it's something that has an engineering report on it, we're pretty much willing to do that. So there are a lot of options that I think builders don't often think that they have an option on, or maybe they just haven't been exposed to something like that. It could be anything from anchor bolts to, to joists, to trusses, to wall framing, to methodologies even. We have some builders that prefer to build to a specific client, and so their client maybe wants ultra efficiency, and so they're doing things very differently than just basic code minimum.
Right.
And it even goes as far as headers. Just for an example, we have some clients that prefer to use like an engineered wood header that's thinner, and you can put more insulation in than just a standard 4x or 6x type header. Connections to trusses. There's options for connections to trusses, and if someone has a specific preference, then we like to know about it because we like to make people happy.
Right.
So, hey, if the builder's happy and it's easy for them, then hey, great. It just saves headaches in the field. So there are a lot of different things that people could come to us with information and ideas. And even as far as, everything under the sun. Well, there's not everything under the sun because we just got exposed to a whole new building method just in the last couple of weeks that we're working on engineering right now for something that's like bamboo core walls.
No
and
kidding.
so it's still eliminating a lot of bridging in the wall, but it's just it was all new to me. And so, but they had an engineering report and they have support for it. So it's like, hey, sure, let's go for it.
Yeah. Yeah.
It might add some engineering cost. It might add some extra time on our end to figure it out. But if it's fairly small, generally that cost is fairly small up front compared to maybe the overall cost of the house. And if it means you get to use whatever you want, then hey. And overall, production building and the like, oftentimes small changes to the assemblies, just like in your guys' pre-manufactured wall panels. Like if you have small changes that enable you to piece together a system quickly and efficiently in the field, it saves the builder time and money.
Right.
And so you're talking pennies on the dollar usually to customize your engineering or the methodology of your engineering up front to give you a real slick final production in the field.
Right. Awesome. Yeah, and we know that those even a small savings in one area, when it's multiplied out over many uses, ends up being quite a bit. So it sounds like if I was a newer builder or just a builder that wanted to learn about the best ways to do things, we've all heard, we've always done it that way. And fortunately, there are a lot of people that say, well, we've always done it that way, but that might not be the best way. If someone came to you and said, you tell me, how should I build this structure? Is that something that you guys are open to or prefer, or would rather not have quite such a blank slate?
I don't usually say, no, this is how you should do it. I'm more comfortable saying, well, here's some options. I'm not a builder. I'm not out there full time, and certain people have just certain preferences towards the way they want to do things, whether or not it makes sense cost wise or not. Sometimes it's just a familiarity with a certain thing that makes it more doable for the person in the field. So in general, I would say, hey, these are some good options. Hey, this is what we've seen done traditionally and it's worked well.
Yeah.
And if someone has questions about a specific item, a specific portion of the building, then I would say, hey, okay, why would we hang our joists in this situation? Why would we drop the joists or the trusses below that plate and hang that versus just doing a traditional stacked system? Weighing those costs, or weighing the advantages and the disadvantages, and just looking at what makes more sense maybe for the building and for the site and for the crew that they have in installation. Yeah. And then they can weigh those things out and go, oh yeah, no, that would be way easier. Okay, I'm going to do it that way.
Right.
So
it's a discussion. It sounds
it's a
like.
discussion. Yeah, it's
excellent.
definitely a discussion. So.
Yep. I'm sure that the builders appreciate that it sounds like you're coming into it with an open mind, just like you'd like them to come into it with, and the best results are going to come out of collaboration.
Yeah.
Definitely.
Yeah. So, I'm curious to know, where do you guys see the industry going? And we can talk about, the building industry in general. I'd like to know about, engineering. What do you guys see coming up and changing things over the next 5, 10, 15 years, or, however far out you're able to see?
Mm-hmm.
Not sure on that one.
Not sure. Well, one of the big things is energy. Is how do we heat and cool the buildings, and what is the state going to continue to do that's going to affect the building? I think in general that affects the trend in building more than anything else in our area. Is just the codes, and more specifically, the energy code. So people are starting to look for alternate products or alternate means and methods to be able to meet those requirements and or exceed those requirements. And especially if energy becomes more expensive, which in general it has become more expensive, even though we live in a state that has plentiful energy and hydroelectric that's clean energy, should be clean energy. Still, there's a big push for that green energy. And what are we going to do? What are going to be the requirements going forward? I think it's just going to affect, how the heating systems and the cooling systems in people's homes, as far as how they're designed, where they're located, how does that fit within the structure of the house. I think insulation and our traditional walls, the way that our traditional walls are built and framed, I think will continue to evolve. I see a lot of, there are more and more homes being printed, but this is not in our area in general.
Yeah.
It does not make sense in our area unless you're willing just to spend a lot of extra money and take up more space, because when you specifically thinking of the concrete, you got the concrete printed homes, and that's a trend that may continue, and it may expand even, but I don't think it's going to really hit in this area unless something changes with our building codes.
What do you see as the barriers to that?
Insulation.
Yeah.
It's maybe you can throw up a house, you can concrete print a house, but then you are then having to install insulation and install how do you make that house tight and insulation and energy efficient. If it's concrete, it's just, unless you're doing an insulated concrete form, ICF type construction, it's really hard to make concrete energy efficient.
But that's not the printed, and so that probably takes away a lot of the labor and time savings that the printed house kind of promises. Yeah.
I don't know. Conceivably, could it happen? Could they get to a point where the concrete printing becomes so efficient that it doesn't matter if you have to come back in a house and reframe the walls and insulate them and still make sense? Maybe. I don't know. Yet to be seen. But
right. Do you see a path with a concrete printed home where seismic works in this region?
I don't know. Maybe if there's specific admixtures and they have testing on it, maybe.
Yeah.
But in general, wire reinforcement doesn't cut it around here for seismic. And so that would be another big barrier.
Yeah.
Yeah. So.
Interesting.
Work with that micro rebar?
The micro steel or there's like microfibers that you can get.
Really?
Yeah. So that's what I'm talking about.
Oh,
it's
like
like maybe an admixture.
Yeah.
Something that you put, it can go through a nozzle and be pumped through a small orifice.
Yeah.
That maybe is
like a fiberglass
but
something
steel.
That's,
it would need to be steel. It'd have to have some high tensile strength and have a good bond. And then it'd have to probably go through testing. It'd probably have to be code approved or have an engineering report that says, okay, this product specifically set up in this test situation can resist
highly
X amount of
corrosion resistant.
Yeah.
Interesting.
Yeah.
Yeah. All right. So I've asked you guys quite a few questions and really appreciate the answers and the insights. And are there any questions that I should have asked you guys that I didn't think to ask? Anything that you'd just like to be able to share?
Comes to mind.
Yeah, I'm not sure, I guess, because you've asked plenty of questions, good questions. Maybe a question kind of going back to you. Do you see much in the truss industry changing? And how do you see it changing, or how do you stay competitive? Because trusses seem to be a very, at least in my purview, at least a very competitive industry to be in when it comes to building.
Right. That's a good question. As soon as I figure that out, I'm going to run with it. No. Yeah. No. In reality, I don't see a whole lot changing as far as trusses go regarding materials, and I've explored that actually quite a bit, especially. In 2020, mills were shutting down and big scares about lumber shortages and that sort of thing. And typically, the necessity is the mother of invention, right? So what other options are there out there? And the lumber is definitely the most available, even when it doesn't seem like it's available, and most cost-effective material to use. Steel trusses are popular in some areas. I see them a lot more in commercial, but in areas where pests are a big deal and that sort of thing, you'll see them in residential, but not so much in this area.
Usually are required for longer spans. Usually longer spans or bigger spacing for commercial.
As far as like light gauge steel trusses, yeah. No, not bar joists.
Not bar joists.
Yeah,
Okay.
yeah, but
You're like cold form steel truss.
Yeah, cold form steel.
Okay.
Yeah,
Okay.
thanks for clarifying on that. So not a huge demand for that in this region.
Okay.
I'm sure partially because we're right in the middle of all the forest land, and lumber is available and relatively inexpensive. What I see is driven mostly by home design. Like you mentioned a bit earlier, when I got my start in the truss industry, right after trusses were invented, it seems like, houses were a lot simpler. And so, it was more common for a complex part of the home to be stick framed and the simple part of the home to be trussed. And with software advances and just architects pushing the envelope, and then truss manufacturers meeting that, and then the envelope being pushed again, we've gotten to a point where there isn't much that we can't do. And so it's pretty much driven by building design. I definitely see more low slope, shallow truss systems, especially as the population gets more dense and we're looking at infill and people trying to make the most of small lots, rooftop decks, stuff like that. Floor trusses I see becoming a more and more widely used option as we're trying to get energy points, longer spans. A couple of years ago especially, I-joists were very scarce, and I think that caused a lot of people to check what their options were. But in general, I do see off-site manufacturing, and I guess we'll just call that anything that is assembled off-site, becoming more and more beneficial to the contractor. As we have tight lots that don't have a whole lot of room for material, with material prices increasing to where theft is more of a problem, and then the skilled labor shortage, which I don't know that there's an answer for that in sight in the near future. And so anything we can do to just make it simpler and faster to put a structure together on site.
Yeah.
We talked about roof trusses, floor trusses, pre-manufactured wall panels are an option, and pre-manufactured staircases. Just about any any part of the structure can be assembled off-site if it can make sense to ship it there.
Gotcha.
Yeah. So, and remaining competitive, there's a lot of different things going on. There are, as I can recall, at least 3, if not 4, fairly fully automated options for building roof trusses. It's pretty expensive, big barrier to entry.
Yeah.
There are some manufacturers in our state that have taken advantage of some of that.
Okay.
Most of them not so much, but there are varying levels. It's a wide spectrum from where we started out building on concrete floors with the jigs being just snap chalk lines and using sledgehammers to set all the plates.
Yeah.
To having robotic arms that place all the pieces and set the plates and that sort of thing. So a wide spectrum. And to remain competitive, I think probably any truss manufacturer, their best asset is the people that they have solving the problems that the builders are faced with.
With an ever increasing shortage of labor,
Mm-hmm.
yeah, that's probably. I mean, how many employees do you think that you'd have involved directly in truss production?
So personally, it varies for the season, but our company tends to run about 20 people in truss production. If you average it out over the course of the year, we're a pretty small company as truss plants go nationwide, especially, but even in our region. So can't get the job done without the help.
But the efficiency of your employees, right, and short of going fully automated, plays a huge role in your competitiveness, right?
Yeah, it really does.
So being able to retain good employees, that's key for me as well. Having good employees that I can rely on, that I know can handle the drawing and the technical aspects of engineering and drawing a house, to where they're doing 95% of the work that I then need to review and check, maybe as the licensed engineer that signs off on stuff. Now, obviously that varies from job to job.
So what do you do to improve your retention? What do you do to keep your employees around?
I stock the pantry.
It's true.
Not a bad plan there. Yeah.
I try to have a really relaxed work environment. I try to keep it low key, and we have a lot to do. We have a lot of thinking. There's a lot of mental straining going on when you're trying to track loads and figure connections and all of that. So having just trying to have a relaxed work environment where I'm not standing over their shoulder going, "Oh, did you do that right?" That type of thing.
Yeah.
And just trying to give space for and be, just be laid back. I try to have a laid back atmosphere to kind of keep things good for the people and give them space to do what they need to do. And I mean, so far, I guess as far as retention goes, I've done just fine at that.
Yeah.
I've been blessed with some good employees that have stayed with me since they've been hired on. There's a balance there too. You have to try to have a drive for your employees to continue to strive to do work and to do it well, and yet still have them satisfied enough to come back and day in and day out, and trying to be competitive in wages and with benefits, and but it's hard to run a business. There's all these things that you have to take into account, and so I'm trying to do that the best I can, balance all that.
Yeah, not for the faint of heart, for sure.
Yeah.
I'm going to take a real chance here, and if this goes sideways, we can cut it out, or you can just say, let's not go there. I'm trying to build it up really big, so it's just not that big a deal when I ask the question.
All right.
But I'm going to ask you, Chris. So since we're talking a little bit about what helps a business be appealing to employees and help them stick around, what does Exodus do well? Why is it that you like to work there? And obviously you have because you've been there a few years. What could other employers do to kind of match up with what Exodus is doing to help them retain their employees? And then this is where it gets really scary. And you could answer this or not. It's up to you. What's something that Exodus could do a little bit better?
Yeah. All right. So, yeah, pretty much everything that Luke outlined is all correct. Coming down, I worked in Tacoma and came down here in 2016. And
Got him to relocate even.
yeah, got me to relocate. Yeah, and like I was just saying, everything that he said was correct. He's very laid back, and I think that's one of my favorite things about the office is that there's very little micromanaging. And he like you said, he's not standing over your shoulder, do this, do that, you did this wrong, and it's just very laid back. It's here's your assignment, get it done, let me know when you're done, and that's kind of that. As for what we could improve on, that's a tough one.
I really did put you on the spot.
repercussions.
So.
Please, speak freely.
I would say if there was one thing that we can improve on, it would be Luke's availability. That he's got a lot on his plate, which it's fine. He's got a lot on his plate, but that leaves him spread kind of thin. So just a little bit more availability from him.
Yeah.
But
All I need is
not a
more
complaint.
time.
Yep. That's I'd be lying if I couldn't say I've heard the same thing. So yeah, but that's one of the benefits of being the company owner is you are in high demand.
That's right.
Yep.
Yeah.
Yep.
Yeah.
Very cool. Well,
How are you guys dealing with an increased demand in use of solar panels in Washington?
Oh, great question.
And how does that affect trusses? And what happens when someone comes to you with their 1970s or 80s house with engineered trusses and they go, "You're a truss guy. How do we tell if this roof can hold our solar panels?"
Yeah. Okay, so that's two questions there.
Okay.
I'll try and remember the second one as I answer the first.
All right. You can just cover the first one. If we don't
Yeah.
get to the second one, that's okay.
No, that's fine. So the first one, fortunately, modern solar panels are pretty lightweight, and generally it's pretty safe to assume that when they're talking about a solar system, they're not talking about a wet system that might weigh a little bit more. So we will typically just put 5 pounds per square foot because we know that that's going to cover just about any modern solar panel. What we like to know is where the solar panel system is going to go on the roof, and if we know that, then we'll just design that portion of the roof for it, which can make the job a little more economical. If it's our local jurisdiction here has now passed a requirement that all new construction needs to be solar ready. And so that being the case, we're adding an extra 5 pounds of live load actually it's dead load.
Should be
we're
dead
adding,
load,
yeah,
I would
we're
think.
adding 5 pounds of dead load to I got a little mixed up there because I've actually seen some plans come through with additional live load as well recently, which makes no sense to me at all.
Okay.
But anyway, extra 5 pounds of live load. We don't know what the panel system is going to be. We don't know where it's going to be. On your typical short span truss system, it's not going to impact it significantly, if at all. But if you've got a bigger than 1,500 square foot house on a single level or a multiple level house that's got longer spans, then it starts to drive the cost up. There's no two ways about that. So like most things, and not to get into a rant here, and I'm sure we could all talk about it for a while, but the answer to the affordable housing dilemma is not making homes more expensive. But every solution that I see seems to make things more expensive. So not sure where to go with that.
Oh, believe me, yes, we share a large frustration with the state on that level. Oh, we need more affordable housing. Oh, let's drive the cost of homes up more for energy efficiency.
Yeah.
Yes.
Yep. It is definitely opposing interests. As far as the home that was built in the 70s, well, let's start with the home that was built last year.
Okay.
That they want to add solar panels to. So in that case, as a homeowner, you might be fortunate enough to be able to figure out where your trusses came from, and very likely, if the trusses were produced within the last 7 to 10 years, the truss plant that did them will have engineering on hand, and so for a fee they can have their original truss engineering reviewed and see what the changes would be. If it was built more than, I'd say, 7 years ago, then it's really going to come down to having a PE such as yourself check the trusses individually. And then hopefully it was built with a truss plate that is still available and you can find values for and that sort of stuff. But
Which typically isn't the case.
Yep. So I wish I had a good answer for you on that one. But that's kind of asking a question that wouldn't only apply to solar panels.
Sure.
If you have an issue with trusses and the desire is not to replace them, but to modify them, unless you have your original engineering and the manufacturer that built those trusses is still available and in business, you're probably going to have to bring in a PE who's going to have to do manual calculations. Yeah, we can, as a truss manufacturer, help you out as a PE because we can design those trusses in order to just develop the loads and the forces that are in the members for your review. But I don't know if that makes a whole lot of sense or not.
It does sometimes. Sometimes it's helpful because you guys can fairly quickly come up with a configuration that matches maybe what we're trying to simulate, and so that can be very helpful.
We have done that with repairs in the past too.
Yep.
I know it's very difficult when someone has an older home though, and then they, even older, being 7 to 10 years older, even if it's not terribly old, but someone has come in and cut out a web or modified a truss or something like that, and then oftentimes we'll get a call that says, "What can we do with this?" And I think, it'd be better if you could talk to a truss company. But yeah, occasionally you just have to come up with, if you want to help them, if they are stuck, then they may need some manual calculations to figure out how to repair what they have and whatnot. But kind of going back to the solar question, I was curious how much actual change maybe happens either in the cord sizes or your webs when you do end up adding, say you add an extra 5 PSF dead load to one area of the truss or maybe the whole package.
Right.
Are you increasing plate sizes? Are you having to increase grades, or what would maybe typically happen in that case?
Yeah, I'd say all of the above, and it's going to depend on a lot on the span of the truss,
Sure.
And the pitch of the truss as well. A steeper, shorter truss span wise is going to have a lot less issue dealing with a little extra loading than a long span, shallow pitch truss. But the progression is going to be, typically your joint plate sizes are going to increase first. Next, your cord grades are going to increase. And then after that, it's going to be additional webbing. Yeah, but it would be a progression in that fashion. Historically, plate size increases weren't very substantial in the end cost of the product. But over the last several years, the steel prices and plate manufacturer selling prices have become more impactful on the end cost of the truss.
Okay.
Yeah. So, there just isn't when you ask more of the truss, there's generally not a free answer to that.
Yeah.
And our desire is to provide the package that has the best value, which is going to include the best performance over time. And so we're not only going to be looking at does the truss work, But if it's a vaulted truss, we want to make sure that its deflection is going to be within acceptable limits. Sometimes we'll decrease spacing if we need to. Another thing is kind of interesting, but little aside, is you can have trusses that are identical on a run, but have breaks in interior walls and that sort of thing, and then end up with trusses that appear to not be performing where they're not crossing interior walls and that sort of thing. And so, we're trying to look at it holistically. What can we do with the loads that we have to work with to make it a truss package that's going to have the best useful life, aesthetically as well as structurally.
Yeah, that's good.
And when I say aesthetically, I don't mean like, pretty lumber. We're going to put a ceiling on it. We're going to put a roof on it. But we want those ceiling and roof planes to stay nice and the way they're supposed to be.
Right.
Yeah.
Right.
Good questions.
Yeah.
Appreciate those. Yeah.
We've, I think our standard as of late has been to include an extra 3 PSF. Just from the couple of manufacturers that we've looked at. In general, the more modern solar panels that go up on a roof typically ends up being about 3. So we're kind of just throwing in an extra 3 for solar. People might not know, right? People don't know today if they build their house, if they're going to want solar. It might be 3 or 4 years down the road. They think, oh, hey, I really want to put this solar kit on my house now.
Yeah.
And so we're kind of just doing that as an aside to include a little bit extra allowance. Say 5 years down the road, customer comes back to us and says, "Hey, you engineered our house. Can I use solar?"
Yeah.
And just the frequency of it being used now makes sense for us just to go ahead and throw it on there without saying, "Oh, now you got to rip open your walls and change your headers, and now you got to do this."
Yeah.
So it's definitely a more common aspect to the building industry.
Yeah. Interesting. Well, any other good questions you guys have?
I'm curious if you can tell us a little bit about the walls you guys are working on.
Okay. So we've actually just wrapped up a pretty good project in your guys' backyard.
Yeah.
Pretty excited about that.
Centralia College dorms.
Yes. Yeah. Very excited. And the contractor is on a very tight schedule on that. We started delivering wall framing toward the end of February, and they have a move-in date, I believe, of September 1st on a 3-story building that I believe is going to house about 100 students. So on this particular project, it made good sense to them to shorten their framing cycle, and so they've been using the pre-manufactured wall panels. So really, the only difference between our pre-manufactured wall panels and a site-built wall is really the length of the walls that are being tipped up. So we build our walls in lengths up to 16 feet, and they're studded to match the plans. So 2x4 interiors primarily, 2x6 exteriors, CDX sheeting. A real fun part about it being a 3-story building, we had 3-inch by 0.148 sheathing nails, and
wow.
that I would have I've learned something, and that would be go to the engineer early on and ask for a tighter spacing with smaller nails, because those were a bit of a challenge. But really, if you were to not see the installation, but just go to look at the structure, I don't think you'd be able to tell that it wasn't built on site. So it's really about having a dedicated space. We've got a semi-automated process. Everyone's working, at a waist level as opposed to bending over and working on the ground. And our automated nailing makes for very accurate spacing, and so we're able to, we don't need to you see over nailing a lot on job sites because they just want to make sure they're not overspaced. So we're able to build the panel pretty much exactly to the engineering specs, which makes it more economical. And then for the builder, it cuts the hours on site by, I'd say conservatively half.
Oh, wow.
It's really probably a better savings than that. But where we have access, we'll crane the panels actually into place. And so out on site, we show up with a truckload of walls, a couple of framers up on the floor system. They just receive them in a standing position, put them in place, brace them off, and then grab the next one. And so with very few people, fast progress is made. Yeah.
Do you just have a single top plate then, and the second top plate gets installed in the field, or how does that work?
Yeah, that's and that's an option that we've chosen to do. We've done it both ways, and our experience has been that pre-installing the top plate, it takes longer than the benefit that the builder receives because we have to do it in chunks so that we get adequate splicing at the panel edges. So, and that's probably the biggest difference you'd see between the pre-manufactured wall panel versus a site built is every 12 to 16 feet, you're going to see 2 studs.
They
those
join
are edges.
at the sheathing.
Yep.
Nailing requirements, if there are more strict nailing requirements, who inspects that? Does it get inspected here then, or do they still have to inspect on site?
Yeah, so that's a really good question. I don't know if I want to advertise this, but I'll just say what we did. In this particular instance, we were requested by the contractor to install the gypsum fire rating. I don't even know what the right fire stop, the fire barricade, whatever. The dense glass on the exterior of the wall here in our plant, which of course means that the sheathing nailing can't be inspected on site. So they have a third-party inspector as opposed to just the local jurisdiction doing their on-site inspections. And he actually came up to our plant a couple times a week, inspected all the panels that we had produced, and then we would put the gypsum on after he did his inspection.
Yeah.
We can, apparently, we've learned, do the double layer wall, the cladding in addition to the structural layer, but I don't know that that's something that I would offer necessarily. We have looked at and may pursue a third-party certification. Similar with the roof trusses, we're required to have a quarterly inspection, and then we're allowed to have a third-party inspector's certification that we build our product correctly. And that way, every truss doesn't have to be inspected here in our plant or on site. And our long-term goal, I think, would be to have that same kind of certification for our wall panels, but that would also mean that the jurisdictions would need to accept that. Because I'd like to send out our panels at least house wrapped. It would benefit the builder, and for us here in-house, we wouldn't need to worry about the panels getting wet when they're in storage.
Yeah, I think if you do that, I'm not sure that you'd be able to go through a third-party approval like you would with your trusses. In general, it would mean special inspection, which means the third-party inspector would need to come and view the nailing. And it doesn't have to be continuous. It can be a periodic review, but you have to give that authority then to the special inspection agency or inspector, and then they have to provide the reporting to the jurisdiction. But that's generally how it works in commercial construction.
Is it?
Yeah. And so if you have, it's not for every element of the building, but for elements that require that special inspection, which would include the shear nailing if it's 4 inches on center or less. And so when your edge nailing is 4 inches on center or less, you're supposed to have special inspection for that. But it can be a periodic, and then they have certain frequencies where they say, oh, well, I have to come out once a day, or how many panels you're putting up, or whatever. And then they can in general just approve it. And then the building official is still responsible for ultimately giving a final on things. But in general, at that point, they're usually just looking at the reports
Right.
and verifying maybe a small portion of that in the field.
Mm-hmm.
So,
Oh, that's good to know.
Yeah.
All right.
yeah. I can't think of any other questions right now.
Okay.
I can't either.
All right.
Yeah.
Well, let's go ahead and wrap it up. And it's been a fantastic conversation. I'm
Yeah.
so appreciative of you guys coming up here today. And for anybody that has listened to this and thought, I'd like to get some more information, I'd like to use your services, how could they get a hold of you guys?
Yeah, well, I appreciate the time, and thank you for inviting us up here. It was kind of you to buy us lunch and introduce us to the World Wide Web. Exodus Engineering. You can reach us. Our office number is 360-345-1566. And then you can reach me via email. A lot of times email's better because I'm moving around a lot and unavailable part of the time.
We want you to be available for Chris. Yeah.
But my email is luke@exodusengineer.com. And the one thing is there's no ing on that. It's just luke@exodusengineer.com.
Excellent.
Yeah, so.
Yeah. Well, thanks for a
Yeah.
great conversation.
And there goes the cup.
It was empty.
It was
We don't
empty.
need
Thank you.
Yep.
Yeah.
Yep. You
Thanks,
bet.
Chad.
And thanks for listening and watching today. And there's that silenced phone. We'll look forward to seeing you next time at the Northwest Builders Lunch Hour, hosted by Truss Components. I'm Chad Johnson. Thanks a lot.
This meal was brought to you by Truss Components of Washington. Make sure to subscribe so you don't miss the next hot dish. And feel free to invite a friend for lunch next time.